Okay, let's kind of walk through a couple things here. We're in 8.1. This will be like one of the last days we take major notes on it. I would probably expect tomorrow we might get an assignment on this. It'll be relatively small compared to this last one. I consider that quite a few problems. This one will be significantly less because there's not a lot that's in these sections, but it takes a lot of prep work to try to talk about like the math that's involved and what you're supposed to be doing. Like I know we just started radicals yesterday, trying to talk about how to simplify them by hand. That's still going to be a part of the homework that you're going to have. We have 2 new formulas today that you will need for the homework that you're going to get. So like today we're going to intro them. We'll do an example or 2 of that. Tomorrow we'll do a couple more examples, and then probably in the middle of class tomorrow we'll get an assignment. So that's kind of what you can expect for the next couple days in here. And then next week, obviously, we're going to go to the next section, 8.2 and 8.3. And so kind of, I said about middle of next week, end of next week, we'll start reviewing, because we're almost at the end of our chapter here, end of chapter 4 technically, which is all about triangles. I've been trying to give you all these properties about triangles, so we'll start reviewing here pretty soon. And I'll try to keep you up on that. So we're having a test, not next week, but the week after at some point. I think I had said like Tuesday-ish, but that kind of gives you an idea when we're going to start reviewing. Okay? All right. But let's jump right in. This is the same section 8.1, but we have some new stuff to talk about today. It's incredibly slow. All right. Why is it going right more? All right. Well, we have to review, and we have to do a couple new notes today. So one of the things we have to talk about is we have to talk about radicals and roots today. Radicals and roots is something we talked about yesterday. How to break down square roots and go through that. We're going to do that again today. I want to start in the beginning here, talking about some of those. So I might actually turn on the lights here today just to talk about some roots, and we'll do a couple examples, and we'll talk about some properties, some basic things about radicals. You guys seem like you were following with me a little bit yesterday when I did my 3 examples. But today is more or less I want to try to see if you can handle some. If I give you an individual problem, could you break it down and see if we can get to the right answer? And I'll walk around the room a little bit, so I'll turn on the lights. We'll do that here right in the beginning. Then the next thing I want to talk about is Theorem 8.1. We did this one yesterday, so if you're gone, that was the new theorem we talked about. There was no formula to that yet, but it is the setup for the next 2. The next 2 are 8.2 and 8.3. Those are the next 2 we have to cover today. These are actually formulas, like what we're going to get set up here. Now, I know when you first see it, it's going to look super difficult and super complicated, and because I'm going to have letters and stuff. But once you see a couple examples, I think you'll kind of mellow out and you'll see that it's very simple. And it's one of those things like if we're doing a test, that formula is something that you'll see on the board somewhere, but you have to know how to use it. Okay? Then after this is all done, if we can get to that, we'll talk about the geometric mean, which is basically, the geometric mean is what these formulas are actually talking about, but it's applying radicals. That was the whole point of why I introduced radicals yesterday. It seemed kind of weird that we were talking about right triangles, but then I suddenly jumped to square roots. This will tie in perfectly with why these fit so well together. You'll see it. But this is a huge part of these 2 theorems. Okay? Homework is due today. Keep that in mind. At some point today, get that turned in. And I'll get your grades up to date this weekend and stuff, so you can see kind of what you're missing and what you need to do. And I'll keep you up, and I'll probably try to send out an email if you're missing any major stuff. So, but I think we've only done a few homework assignments so far. Okay. Questions on the kind of the order we're going to do today. Okay, but this is our kind of first priority. I want to talk about radicals, and I'll click the lights on once we get through the vocab, and we'll try out a couple. Okay. All right. So big thing about radicals, remember, there's different types of radicals. There's square roots and cube roots and etc. Remember what they look like. Radicals look like this, where they have that little house symbol. That was the same symbol I showed you yesterday. They'll put things on the inside where you have to break down. That's the goal today. When I give you an example, I want to see, can you break down radicals correctly today? Okay? Vocab terms. The big thing I want to discuss today is, do you know what the radical sign is? Do you know what the radicand is? Do you know what an index number is? That's huge for this picture, right? This is the one I showed you yesterday. The radicand is the number on the inside. That's the number you are trying to break down, okay? Or trying to find the perfect root of it, whatever type of radical we're doing, okay? The index number is super important. When you're breaking this number down, you're looking on this particular problem, you're looking for triplets, things that match up in threes, because that's what the index number tells you. It tells you how many you're looking for, how many items should match. Okay, and then the radical symbol itself. Now again, we don't call it a square root symbol, it's called a radical sign. It represents any type of root, not just square roots. In this case, that's called a cube root, because it has power of 3. Okay, once we do a couple examples today, remember the goal here is we're going to do the principal square root. That's the major goal. Can we do the principal square root? And then simplest radical form will be the second part we're going to do. Okay? All right, questions, comments about what we're going to be talking about here. Now I'm going to click the lights on. We'll do a couple examples on the board here of radicals, and I'll show you kind of some stuff that I had a lot of questions throughout the day. You know, different sections had different types of questions about these, like what would happen in certain situations. That's what we're going to talk about today, and then I'll give you a problem or two that we can try to see if you're somewhat comfortable. You should not need a calculator for these examples I give you today. You should not. I'm going to try to pick very kind of easy-based problems that hopefully you can break down on your own and you don't have to think about them too much. Okay? Make sense? All right. Let's jump right in. Let me get rid of the PowerPoint here and we'll do a couple notes. Okay. Okay, so let's get rid of the PowerPoint here, and let's talk about what the radicals are. So we're going to start with square roots, and we'll kind of move our way up to the more difficult types. Okay, this is a square root. How I know it's a square root? The index number, what's the number on the outside? It's going to be a 2. If they don't have it printed on the actual house, the radical, it's always a 2. It's the one number you can assume that's in that radical. So we have an index of 2, but again, they will not print that if it's a 2. They just assume it. Now they'll have a number on the inside. This can be any number you want. Let's say I put a 36 in here. Okay. What you're trying to do is on this particular problem, you are trying to figure out two numbers, because index numbers are 2, two numbers that would multiply together that would give you 36. Now, I know there's a lot of combinations that give you 36. Like, it's what, 1 and 36, 2 and 18, 3 and 12. There's a lot of combinations that can give you 36. But I'm looking for numbers that multiply together that is the same number that would multiply to give me 36. 6 and 6, right? 6 times 6 would give me 36. So the answer for this problem is the number that multiplied on itself. That's what you're looking for. Does that make sense now? Okay, I'm looking for the one number that would multiply together that would give me the 36. There are certain numbers that are called perfect squares. This is a square root, right? Perfect squares. These numbers, I'm going to put this up here. So these are the perfect square numbers. These numbers are the numbers you can take square roots of, and they turn out to be nice, pretty whole numbers, no decimals. Here's the numbers, and I'm just going to go in this big list. 1, 4, 9, 16, 25, 36. These numbers are pretty obvious. These are the ones that most people can think of. Then we go 49, 64, 81, 100, 121, 144, 169, 196, 225, etc., etc., etc. Now I know this list looks completely random. Now, Ward, how do you know those numbers, right? How are you making that list of perfect squares? How do you know that these all have perfect, nice whole numbers? Well, how I memorize this list, it's not really a hard thing to memorize, because to make each of these numbers, all I did was take 1 times 1, 2 times 2, 3 times 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's all I did. So I just multiply those numbers in my head, and those are the numbers that I have, right? These numbers, all the ones I haven't written in black there, they are all perfect squares. So when you take the square root of any of them, let's say you're taking the square root of 9, square root of 9, you're trying to figure out the number that would multiply on itself that would give you 9. Two numbers that would multiply to give you 9. Well, it's this. It was 3 times 3. So the answer is 3. That's the number that would multiply on itself. And now, the other way to think about this, if you really don't like that, you could go down the list and just count what number is it on the list. Well, that was the third number down the list, so that would be the answer for it. Or if you're doing 36, that's the sixth number down the list, so the answer would be 6. You could do it that way. But the scary part about memorizing what number it is down the list, what if you don't write them all? You forget one, and you're counting like, oh, it's the 7th number, so the answer is 7, when it's not. Maybe you missed the number 49. Now, if you're not into that, where you like to look at this perfect square list, like you know, like these are the only numbers and there's more, but these are the only numbers that give you perfect whole numbers. Everything else will give you a crazy decimal, like irrational. Okay? So, how you could do this. Like another way to do this problem is that shortcut I was trying to show you guys yesterday. How can you do this problem if you didn't have it memorized? Like you didn't know that 6 was the number that multiplied to give you 36. Here's how you could do it. Number 1, you have to look at the index number. My index number on this particular problem is a 2. Okay? It's a 2. So, what you do is you break down 36 into any numbers that multiply to give you 36, ignoring the number 1. So what are numbers that you know that give me 36? What are numbers that can multiply, other than 6 and 6? Pick any two.
2 times 18.
2 times 18, okay. So let's say it's 2 times 18, okay? Those are numbers, let's say you just knew that off the top of your head, that 2 times 18 gave you 36, or maybe you're the 4 and 9 person, or 3 and 12, it doesn't matter, okay? Then you break these down even further. So break down 36, or sorry, break down 18. How would that go down any further? 2 and 9, okay? And then you can break down 9 even further. Yeah. 3 and 3. Okay, so we broke down the numbers as far as you could, right? And again, it's in no particular order. I don't care if they're all switched around. You know, maybe you have the 9 in the front and the 2 in the back. It doesn't really matter, okay? But you broke them down. You can rearrange the numbers if you need to so you can group them together. It doesn't really matter because the order doesn't make a difference. And the index number outside is still a 2. And now to prove that it does give you 6, what I told you yesterday is you look at the index number, and the index number is a 2, right? So you're looking for pairs, 2 numbers that match in the house, in the radical sign. So is there pairs in here? Yeah, we have actually 2 pairs. There's a pair of 2s, and there's a pair of 3s. Because again, the index number tells me how many numbers I'm looking for. I'm looking for 2 numbers that match. That's what the index number is telling me. Okay, so if you have a pair, the shortcut I told you yesterday in the PowerPoint was you cross one out, you kick one out. So one of the 2s is outside the house, and the other one disappears. You erase it. And then one of the 3s, you cross a 3 out, you kick one out. So, what numbers are now sitting on the outside of the house? 2 and 3. Okay, there's a 2 and 3 sitting on the outside. And again, when they're on the outside, they are multiplying together. Okay? Now, on the inside, is there anything left? No, because inside, you've already kicked out all the numbers. There's literally nothing left in the house. So the house can go away because there's nothing left. It's not a 0. There's nothing in there. And now you have, this is the only thing that's left. What is 2 times 3?
6.
Yeah, that's why it works. So there's like 2 different ways you can do that problem. You could be the person where just common sense, like duh, 6 multiplies to get 36, you write it down. Or if you don't want to think about it and you just want to do mindless work, just break down your numbers. Break them down as far as you can and look for how many pairs or triplets you have. That works on that problem. Same thing with the 9. You know, you broke down 9, you know, because we know 3 times 3, but 9 was 3 times 3, right? That's how you break down 9. Well, the index number is a 2, so I'm looking for pairs. There is a pair. You cross one out, you kick one out. So there was a 3 on the outside, and there was nothing left in the radicals. The radical went away. So that was your answer. That's why it works. Question?
If the index number was 3, we have a pair of 3.
Yeah, so if the index number is a 3, we'll do that here in a second. You're looking for triples. You're looking for things that 3 items match on the inside, if there is any. Okay, and we'll do that one.
What if there
Okay.
isn't any?
Okay, so that's a great question. So let's do one with the square root, and then we'll get to our triples, right, our cube root. So let's say we're doing a square root, and the question was, what happens if you don't have like a pair? Let's say we don't. Let's say my number is, let's say we do like the number 70. I'll just make that number up, right? So 70. And we're going to try to take the square root of it. The square root of 70. Okay? So, now, do you agree that 70 is not on my list? so that I know it's not a perfect number. It's gonna be, like if I were to type that in a calculator, it would give me a weird decimal, like a crazy irrational number. And you know, I can actually even guesstimate what the number will be, because on this list, if I have them all listed, all the perfect squares, 70 is in here. It's between 64 and 81. So the square root of 64, right, the square root of this number is 8. The square root of 81 is 9. Those are the numbers that would be the perfect square, because that's the 9th and 8th and 9th number down the road. So if I were to type that in a calculator, it would tell me a decimal between 8 and 9. And I can guesstimate because 70 is a little bit closer to 64 than it is 81. Okay, it's 11 away from 81, it's only what, 6 away from 64, so it's like 8.4, 8.3 if I guesstimate. Because I can tell by what it's closer to. If it's right in the middle, it's almost about 8.5. It's in the ballpark. But right now I know it's not a perfect number. So now to answer your question there, Nelson, what happens if there's no pair? This one doesn't have a pair of numbers, right? The index number is 2, right? So let's break down 70. So what are numbers that multiply to give me 70? 7 and 10, that's probably the most common one that people think of, 7 and 10. Then you break down those even further, again, ignoring the number 1. 1 goes in everything, so just ignore that. So let's break down to 10. What is that, 2 and 5? Okay, so I broke down as far as I could, and my index number is a 2. Is there any pairs in there? No. So your answer is simplified. You can't do anything with it. Like if there's no pairs to kick out, you can't do that problem. In fact, since there's no pairs, this answer, the square root of 70, going back because there's no pairs to kick out, that is simplified. The only way you could actually simplify it further or to find the answer is to type it in a calculator. Because I can't do this type of thing where I can break it down. So I can't simplify it. So that is simplest form. It's called simplest radical form. You can't break it down. There's no pairs. That answer your question? Okay. Now let's get to Morgan's here. She was asking what happens if there's a 3 on the outside. Okay, like a cube root, not a square root like I'm doing here. But what if there's a triple on the outside? Okay, so let's look at a cube root. Alright, so let's do a cube root and let's do something like, no, let's do like, I'm going to do a big number, I apologize, because triples, you got to go kind of a ways out. Let's do a triple and let's do like the number 250. No, that's kind of big, sorry. Kind of big. But I think we can break it down. You know, there's some easy numbers that are involved here. Okay, so we're doing a cube root, the triple that we wanted, right? So we can do the same rules I just showed you a little bit ago. Okay, now obviously the 250, we're not using this list. Now why you wouldn't use this list on that problem is because that's a cube root, not a square. So I'm not using a square list. So I would be using the cube list, the perfect cube. So the cube list is a different list completely. So these are the perfect cube numbers. I call it the cube list. Again, why I would do the cube? It's when your index number is 3. When you're doing an index of 3, this is the list you'd use. So here's the numbers. I'll give you a couple and I'll explain how I came up with this list. 1, 8, 27, 64, 125, 216, 343, blah, 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 blah. And it keeps going. I don't have this list as memorized as the other one. Okay, this is the cube list. Okay, now again, how I made these numbers, if you want to know. Now to get the number 1, I took 1 times 1 times 1. To get 8, I took 2 times 2 times 2. So I'm taking triples of numbers. 3 times 3 times 3, give me 27. 4, 4, 4 gives you 64. 5, 5, and 5 give you 125. 6, 6, 6, 7, 7, 7, and then 8, 8, 8, 9, 9, 9, that type of thing. Okay. Okay, makes sense? I think the next number on the list, I think it's like 512 or something like that. 8 times 8 times 8. And then 9s, I think it's like 729 or something like that. So those are the numbers that are, you know, later in the list. But anyways, we're doing a triple here. So this is the question I had earlier. So let's break down the 250, because obviously it is not on my list. So it's not a perfect number. It's not, like this number was 6. This number is 7 for the cube root. So it's between 6 and 7 as a decimal. Probably type that in a calculator if you actually had the luxury of that button. But let's break down. What are numbers that obviously multiply to give you 250?
10, 25.
10, 25, yeah. 25 times 10. I heard, I know some people do 5 and 50. So that was the other one I kind of heard. That's usually the ones that people always think of, those two in particular. But let's break these down even further. Like what gives me 25? Okay, so it's 5. And what breaks down 10? 5 and 2, or 2 and 5, however you want to put it. You can put it in any order. You can rearrange them, I don't really care. All right, and again, you do have to write that little index of 3, because it is a 3, so it has to be printed. They have to give you that if it's a 3. All right, now, what Morgan was asked earlier, what happens if it's a triple? We have a triple in this one, correct? We have 3 5s, and again, you can rearrange to make sure you put them all next to each other. So I do have a triplet, because again, why I'm looking for triplets, the index was 3. Looking for 3 numbers that would match. So I have a triplet of 5s. So the rule was, you cross them out and you kick one outside the house. You always kick out one, and you get rid of all the rest of the triplet, or quadruplet, or quintuplet, or whatever you have. All right, so I'm going to kick one of the 5s out, so it's on the outside. Is there anything else I need to kick out? No. And there was a number left. So there was a 2. So you're going to leave that in the actual radical sign. This is your simplest answer. It's the simplified version of that problem. Okay, it's called simplest radical form. Okay. Now if you were to type this in a calculator, like this part right here, or if you just typed in the cube root of 225, or 250 I should say, it would give you the same answers. It would be the same numbers on a calculator. Now, some people don't have the luxury of having the cube button on their calculator. Some do. I think mine in the back do have that button. It's in, like, you have to hit, like, when you're looking at my calculator, to get to the square root buttons, when you're looking at my calculator screen, you have to hit, like, the little second key. I call it the shift key. You have to hit that little button. And then the square root buttons are down here. It's like, I think it's like, the number 7s and, 8 and 9, it's like diagonal. There's a square root button. Now, to get that, why you have to hit the second key is because the square root symbol is above one of the buttons. It's not on a button, it's above it, so you have to hit shift to get to those capital things that are above those buttons. So it's like when you want to get a capital letter on your keyboard, you have to hit shift, so that gives you the letters that are supposed to be above the actual keyboard. I think Apple just recently changed it. If you're familiar with Apple products like the iPhone, you can drag, like your keyboard, you can drag the button down and it'll give you different options for your keyboard. Now, that was one of the things they've done. You don't have to hit shift anymore. You can like hold the button and drag it down and it'll capitalize it sometimes. Which is kind of clever. I think that was kind of a cool one. But anyways, calculator's the same idea. Okay, questions on simplifying. Okay, here's the thing. I want you to try out a couple of these today. I want to see if you can do some of these where you're using my little method of like breaking numbers down and like kicking numbers out, and do you know how to do it correctly? So I'm going to give you some easy numbers, some very simple numbers here, okay? Because I don't want to give you anything complicated. Like 250 is, I consider 250 kind of out there. That's kind of a bigger number. I wouldn't potentially give you one like that. Well, let's do something like, let's do the square root of 72. Let's have you try that one out. Square root of 72. And let's do a cube. Let's do the cube of 48. Let's do that. Let's do the cube of 48. So again, I want you to try to break these down and see what you're kicking out of the house and what's left. You're simplifying. You shouldn't need a calculator unless you just don't know what multiplies to give you those numbers. Then I can understand why you need to type that in. Try to give you some numbers, you get to have some options. Okay, once you think you have it, I'm going to walk around. I want to check what you have written down, that type of thing. do, and I'll go over and check what you have. Because it won't make any sense going on unless we know how to do radicals, because this will be a big part of the homework today. Or homework tomorrow, I should say. Doing some radicals, simplifying them. Again, you'll learn more about radicals in Algebra 2 and whatnot, but today is the intro of how to simplify them down. Maybe you were lucky enough you saw it in Algebra 1. That'd be awesome if you've seen it in Algebra 1 before. Yeah, you keep, yep. You go as far as you can, and then you can see if you have multiple, like, pairs and whatnot. We're looking for triples. You had, yeah, because you actually had 4, so you did have a triple, and yeah, have your, and then you could combine those down to 6 again, and yeah, have your. Okay, that's right. So far? Yep. Now on that one, you're looking for triples.
Thank you, I'm wondering why I was going by that.
Yeah.
Times
Oh,
4 and something to this.
So far, so good?
well,
Now you gotta figure out what's left. You have the 6 on the outside, and what was left? 2, yeah.
no, they don't.
Yeah. Yep, nice. Yeah, it's good.
Oh, I get it. Okay. I have to find where to get it.
What's 16 times 16 times 16? Not 40. Alright, good, you already solved it.
Did you look for these?
Yeah,
on
just
the
small,
side?
yeah, just small those together. Question? Okay. 8, 9, I agree with that, that's good. What's 4 times 4? Yeah, and that can make 6, because you just multiply those together. And that would make 6, and you'd be done. Okay, and then you can break down the 4 even further too. Because then you have another pair. Okay. That's good. Yeah, that's good.
So get that still right into.
No, because you'd have to break that down even further, because there was a pair. I mean, you were close, you were actually getting there. Don't forget the little power 3 on that radical, that can correct you. Wait. You grab another 2, yeah. Okay. Stop breaking down. I agree with the 4 and 12 so far.
Should I just leave that like that one?
Okay, she has, let's see. Okay, I agree with the 6 and 8, that's good. Lots. 3 times 3.
Oh, shoot.
Yeah, I do think. 2. So one of the 3's is out, yeah, and then you took one of the 2's out. Yep, and yeah, but here's the question. Okay, here's my question. Okay, so we're learning that last line, right? You had a 2, 2, 2, and a 3, right? Yeah. So you had up here, right? problem is that
Oh, wait, that's,
Alright, I think he's fine.
yeah.
Good? Yeah, and then you can just go back to make 6. Yep. Thank you, that's a problem, it's good. It's really good. Okay. I agree with that, 6 and 8, okay, you broke it down as far as you can, and is there, and on 48, I think we're doing a triple, right? Look for triples. So, yeah, 3, so is there a triplet of 2s? Yeah, there's a triple in there, so I agree with the 2s and the 2 and 3s, that's it. So you put that 2 there.
Well, how do I?
So you circle the triplet, right, because there's a little power thing, right, put all 3 in. And so you kick one of those out, so one of those would be outside the house, the other 2 would go away, right? Yep, those 2 would go away. And so what's on the outside is the front. Good? Well, what's left on the inside? Exactly, and just make sure you have a little power thing. Cool. That's the answer.
That's the answer?
Yep, and if you wanted to, you could just combine those to make one number again, but that is how you get your answer. Yep. Nice. Yeah, that'd be the answer. Okay.
Is this one?
Let me double check that.
Agree with 8 and 9?
That's 4 times 4. So, yeah, there you go. And now you can break those down even further. All right. So, keep breaking them down. So you have the 3s, then you break down that 4 even further. And so, that's it. 2, 2, and then another 2. Yeah, so, yeah, now you're playing, all right. Let me check on, okay, you're 6 and 8. You had 8, you broke 2s, you kicked one of them out, and what was left on the inside? 6, leave it in there, and boom, that's it. Because if you break down 6, there will be another triple. So, that's it, save it. Now for the 12 on the top, or the 17, break that one down. And now on that, the top one, you're looking for doubles, not triples. Okay. Good, good. Also, double check. Yeah, there you go, that's good. That's good. All right, anyone else need me to double check, and I'll get yours still going. Okay, double check. Keep that up there, keep that at 2, good. Let's see. 1, 3, 2. Okay, caution. Check. Okay, 2 and 8, right? And 3. Right here, 3. The 8 broke down to 2 and 4, what happened to that 2? Oh, I see. Yeah, but there's an issue. Yeah, it was 4 keys. Okay. All right, I'm gonna walk around the room one person at a time. I know it seems a little funny, but I'm gonna walk around the room one person at a time. I'm gonna start over with Frank. How do you break down your 72? How did you do it?
2 times 36.
2 times 36. Okay. So this may not be the way that you did it. I think there were some other options. Like, what were some other options people picked instead of the 2 and 36? 9 and 8. What was another one I heard? Was it 9 and 8? Was that the other ones that we? Okay. So there's other options in this, but I think 9 and 8 was probably the most common. 2 and 36, you're fine. Don't erase because it's still they're all the same. Because on this work, you're still breaking these down as far as you can. So like 36, if I was breaking that number down, maybe you're the 4 and 9 type of person for 36. Maybe that's the way you like to do it. And again, you'd still be breaking these down. So 4 is 2 times 2. And breaking down the 9, that's 3 times 3. But again, the big thing I noticed, like when I was kind of walking around the room talking to a lot of different people, was the most common mistake people made is they were dropping off numbers. They were like they were just going missing. A lot of people's were. So when you're breaking these numbers down, you need to be accountable that you have every number still accounted for before you start kicking them outside the house. So be very careful that magic numbers don't disappear in the middle of your problem, because that was a common theme. Like on 8s, a lot of people just like numbers would just disappear. Or the one thing that really made me laugh is like a lot of people were doing 8, 9. And then for this one, I had like more than a couple of people said this was 4 times 4. And 3 times 3. Okay, oh, that was a lot of people. Maybe 8, I think it was 16. So there was a little bit of difference there. So just be careful in that. It's a simple mistake, people get going too fast, they don't really think about what they're kind of writing. But again, we're looking for only numbers that multiply, we're not adding or anything like that, we're always multiplying on these, so it's kind of nice how these work. There's no other operations. And then on this, what's my index number outside? 2. So I think I broke this thing down as far as I can. And now what we're looking for is doubles. We're looking for doubles. So we do have a bunch of pairs, like doubles, 2s. So we have a pair of 2s here, we even have a pair of 3s, that's kind of nice, we have multiple pairs. So then what you can do is you can kick them out. So we'd kick one of these 2s out, we'd kick one of these 3s out. So there's a 2 and a 3 on the outside, and again, we always multiply, we're not adding or anything like that. And what was left on the inside that I didn't circle? A 2. Now, the index number was a 2, I know that, you didn't have to write it, but it is a 2. And then a lot of people stop here, that's fine, that is correct. If you want to combine these, you can just multiply together. That's the same thing, these are the same thing to me. But that's how you do that problem. Now, it didn't matter if you did the 8 and 9, if you did it this way with like 2 and 36, you should always get down to the same answer as long as you're breaking down your numbers correctly. But again, the most common theme people were making was like mistakes on like how to break numbers down. Okay? All right, let's keep going though. I think we're on to Adam. How did you break your 48 down?
24 times 2.
24 times 2, okay. So 24 times 2. And maybe some people in this room did do that. What were some other options that people have? 4 times 12, I heard 6 and 8, that was another one. Again, they're all the same. That's the beauty of doing it this way that I'm showing you. It doesn't matter how you break your numbers down, because everyone thinks about the numbers differently, they just know their multiples different. 6 and 8, 4 and 12, but we did 24 and 2. You would just keep breaking these down. You just need to make sure you're keeping track on all the numbers that you have. So, like when I see 24, my instinct is to go 3 and 8. I don't know, that's just me. But some people like 4 and 6. Some people like 2 and 12. Maybe you're that person. It doesn't matter. Because you're going to still have to keep breaking down. Notice, I'm being very particular that I'm not losing numbers. That the 2 is still accounted for, the 24 is still accounted for. And when I break these down even further, I'm going to break down the 8 to be 2 times 4. And notice every number is accounted for still. I'm very particular on how that works. And then breaking down the 4 even further, that's 3 times 2 times 2 times 2 times 2. Because every number is still accounted for. And on the 4 broke down to 2 times 2. And then on this one, notice on the outside, what number was my index number?
3.
You have to write the 3. If you magically stop writing it, it's actually wrong. Yeah, so be careful. You have to have a 3. 2s, you can just disappear. But 3s have to be printed if it's in there. Has to carry down. Now, on this one, like what Morgan asked earlier, when it's a 3, we're looking for triples. And we do have a triple of 2s.
Bailey Galton to company office. Bailey Galton.
So the 2s can jump to the outside. And then what I'm left with is on the inside, because these 2s, remember, you cross 2 of them out, you kick one out. So there was a 2 on the outside, but there were still 2 numbers left on the inside I didn't even circle. It was these. And, I gotta have my little power of 3. And again, you can combine the numbers on the inside so that they didn't go anywhere. You can just leave it as 6. Either one of these was fine, but I'd probably bet not most people have to be. Okay, now I know today we didn't get to a lot of the properties, like I didn't get to the 2 theorems. We'll do them tomorrow, it's fine. So we can always push it back. Today's goal was we need to figure this out. Now, we're not going to go away. It's not going to we're just going to stop doing it. We're going to do a couple of these tomorrow. Maybe not as in-depth as I did it today. But the goal of today was to get square roots and make sure that you had that down. That was the promise I told you the other day. Now, tomorrow is to show you how these apply to right triangles, because we've spent a lot of time on this. Hopefully that helped you out. Hopefully you got a little bit better today. You feel a little more confident with this stuff. If you don't, good thing is we're going to practice some more tomorrow. So keep that in mind. All right, that's it for today. Nice and easy.